So in this video, I'm going to show you how to use the DAQami software to record signals from the Triggy oscilloscope. And in this instance, I'm going to be using the accelerometer, which is an available sensor for Triggy. This black device here plugs in with a rectangular gray plug on the 5 to 8 remote in jack on the front panel of Triggy. So it's receiving its power from channel 8 and it's providing signals back on 5, 6, and 7. In order to accomplish that, we have to set these channels in different modes. The first 3 need to be set in audio, and the last one needs to be set in photocell or response mode, and it needs to be adjusted from that mode so that the threshold is at the maximum 100%. So before we begin using or setting the values on the Triggy front panel, we need to make sure that the oscilloscope is recognized. So to do that, you need to first install the driver. And installing the driver essentially amounts to running the InstaCal software. And once you've run InstaCal, the first time it will find your device and create an entry in the board list with your serial number. Once it's been found, you don't need to do this again. If you've been using the other oscilloscope software, then you don't need to do this. But it is a prerequisite for using any of the software programs, including the one that we're going to demonstrate here called DAQami. Okay, once I've installed DAQami, I can run it by going to the Start menu, finding it in the list, and selecting it. Then when you open the software, you're going to see this sort of an interface. You might not see anything about recent configurations or data files if you've never used the software before. Let's just ignore that. We're going to create a new configuration manually. Don't choose the automatic mode. And to create a new configuration, we need to add a device, and then we need to add a display row or contents to the display row, and we need to add channels. So let's add a device first. So we'll look at the available devices and we'll drag one of them here. So we've dragged the USB 201 device, which is the device that represents the Triggy oscilloscope. And under channels, we only need to enable 3 because we're just going to record from the X, Y, and Z axes of the oscilloscope or the accelerometer. Since the signals will be analog, and analog signals can only be on odd numbered DAQ channels, we will skip 0, we'll choose 1, we'll skip 2, choose 3, and we will skip 4 and choose 5. So that's the X, Y, and Z axes. We're not recording any digital signals, and so that's all we need to do here. We'll click over to sample rates, and the default seems to be 1,000. I'm going to make it 10,000. The maximum would be 33,333. 10,000 should be more than enough for these signals. So now I go back to the display row, and I need to choose what type of display I want. So I want a strip chart, and I need to add some channels to that. So I have my active channels for my device here. So I'll drag those 3 onto the window. Then I can resize this window so that I can see everything. And I might want to save this configuration. So to do that, I will click on this gear icon, save configuration, and let's call it accelerometer. So now I don't have to reset those parameters every time I use it. Okay, so here we see the front panel of the Triggy device. Let's just make believe this is a brand new device. It's not configured for anything in particular. What I want to do is go to the right hand arrow button here, push to the right into the presets menu. And here I want to load a preset. I want to go to preset 5, which is for audio. What that does is it configures channels 5, 6, 7, and 8 for audio, and then I'll change the configuration of number 8. So I'll say select, and I'll set it as the default. All right, then I want to go change the channel mode for channel 8. Remember, we need to supply power to the accelerometer on channel 8, so I'm going to go to channel mode for channel 8, and we'll set that to 1, which is photo or response, which is really just going to provide us a voltage. So I'll say select, and now I need to set the threshold for that channel to the maximum. That channel is number 8. Go up to 8. And you can see, because it was set to audio, the threshold was set to 34.1. I'll just hit the arrow up until I reach the maximum, 100%, and say select, and set that as default. So now I have a power source on channel 8, and I have sort of audio grade recording on 5, 6, and 7, which will capture the 3 axes of the accelerometer. So I'm going to plug the accelerometer cable in, and you see you have these 2 sort of ridges on the top. They fit into this little gap on the connector. So I'm going to plug that in. And if you can move the accelerometer, you'll see that you have some signals coming on the axes of the accelerometer, and those are causing Triggy to produce triggers. Okay, another thing that I need to change on the accelerometer, or the Triggy unit, in order to accommodate the signals from the accelerometer, is to change the DAQ channel assignments. So I'm going to go over to the right to Scope USB, click Select, and I'm going to go into the oscilloscope channel select mode. Now here we're working with the analog signals, so I'm just going to choose where it says Ana, Dig, Ana, and let's say we'll assign that first one to DAQ number 1. It's only going to show me options here for odd number channels because it's an analog signal. So I'm going to select DAQ number 1, and I'll choose channel number 5 to go to that DAQ. I'll do this again, and DAQ number 3, we'll get channel number 6, and then one more time, DAQ number 5, we'll get channel number 7. Remember, 8 is the power source, so it's 5, 6, and 7 that have data. Okay, so we've selected our channels, and we've assigned them to DAQ channels, and we previously assigned which of the DAQ channels we would be recording in DAQami. Okay, I have my freshly created configuration in DAQami, and I have my accelerometer connected. I have my DAQ channels assigned on the Triggy, and I have the DAQ channels selected on the oscilloscope interface. So if I click the green arrow, you'll see that there's virtually no signal, and the software is just auto scaling. But if I shake this around, you'll see the accelerometer signals. So depending on which axis I'm shaking, the signal is larger, depending on the direction I'm shaking it. So movement of the accelerometer within its g-force range will produce a signal. It should be relatively well scaled to the input of the Triggy DAQ oscilloscope. For a very special application of measuring small, higher frequency signals, I'll also demonstrate recording signals from the vibrator or the haptic feedback of a telephone. So I have my phone here, and I will use just a regular piece of tape to tape the accelerometer to the front of the phone. Okay, and I've configured my timer on the phone to just vibrate rather than making sound. So I'll turn the vibrator on. And now I'll start the DAQami software, and you'll be able to see the oscilloscope signals representing the vibration of the phone. So now in DAQami, if I want to record the signal, I can hit stop and then press the red circle, and that will start logging the data to disk. So I'm saving the data to disk, and when I hit stop, then it asks some parameters about how to format the data. Say just yes to the defaults. And if you want to know where the data are stored, you can go here, Preferences, General, and you'll see the path, users, your name, documents. So on my computer, and here I have the recordings that I've made on different dates. So you'll see I have 2 from today. This is the most recent one, 2:25 p.m. So the file is here, it's a CSV. If I double click to load that, I can see it in whatever spreadsheet software I have loaded, and you'll just notice that sample number is here, voltages for the 3 channels are here. So I found it easiest to just swap those 2 columns. I did this in Google Sheets. And so now I have my data, and I can select those columns just to visualize it. I could also import it to another software if I wanted to use some kind of analytical tool. So now we can see our signal is mostly on analog N1, the blue one. The color here is different than the color in the DAQami software. So maybe I want to remove these other axes. And I can see my oscilloscope picking up the vibrations of the phone. For clarity, I want to show the difference between measurements in TracerDAQ versus DAQami. The reason I demonstrated DAQami in this video also is that it offers a higher sampling rate overall, But just to illustrate more flexibility in terms of how you display the signal and triggering and so forth, you can use TracerDAQ. I'll open the oscilloscope interface. I've already selected my device in Instacal, so it automatically comes up acting like it knows the device I want to use. I'll go here to Edit DAQ Hardware Settings. I've selected DAQ channels 1, 3, and 5, similar to the way I demonstrate this in DAQami. I'll say, okay, I've already assigned those in Triggy to the input channels. And if I hit start here, then you'll see those 3 channels they have an offset on them. So that's one point to make. I can't go any smaller than a 50 millivolt scale here, because there's a big offset on the signal. If I reduce this anymore, those signals go off the screen. But even with this very small signal from the phone's haptic interface, which I've just started here, you can see the signal on the red trace here. It's channel 0 or DAQ 0. If I adjust the time scale, you can see the quality of the signal. It's not perfect, but it's adequate to discern the frequency content and the approximate onset time of the signal. And this is a pretty small vibration. Accelerometers are really not meant for this small signal, but it is possible to capture it.